differentiate term by term, and we need to use the chain rule on these instances of y in the equation. So notice that in this one we need to use the product rule and the chain rule. So the derivative of x to the fourth is 4x cubed. The derivative of this product, I'm going to take the derivative of the first factor times the second, plus the first factor times the derivative of the second, and again I'm using the chain rule on that y squared, plus here's that y cubed term where this is the derivative of the outside function times the derivative of the inside, and then differentiating that constant 5 I get 0. So now to solve for dy dx, I'll bring every term over here that does not have a dy dx factor in it over to the right. I'll factor out dy dx from the remaining terms on the left, and this is my expression for the derivative. So let's say that my problem had been to find the equation of the tangent line at the point 1, 1. So then I would evaluate this function when x is 1 and y is 1 to find the value of that derivative. Okay, now one thing, dy dx and y prime are interchangeable, so you'll be seeing that notation used, both notations used in these examples. So here we have another example where we need to use the chain rule at first on the left side of the equation. So my outside function is this power function with the power of 1/2. So here's my derivative of the outside evaluated at the inside, times the derivative of the inside function. So now that I have, so I differentiate term by term inside here. The derivative of x is just 1. The derivative of y is simply y prime. So if you think about it, that's really y to the first power. So I don't have, so my outside function really doesn't apply here. This y prime is really just the derivative of the inside function. So when you see y by itself, it's just simply y prime. And then I differentiate the right side term by term. Again, this y to the fourth term results in this term. We need to solve for y prime. So again, we gather like terms on either side of the equation. So I get my y prime terms over here. I factor out y prime, and then I divide. And the reason I put it in this form is because this example is actually an example from the text that wasn't coded in WebAssign, or it's an exercise in the text that wasn't coded in WebAssign. So those are the examples that I throw in these lessons that are examples or exercises from the book that you should be looking at, even though WebAssign doesn't have them coded. So anyway, this is the form that the answer takes if you look in the back of the book. And then another example is, this is one of those examples where it says to find the equation of the tangent line to the curve at the given point. So this is a hyperbola, and we want to find the equation of the tangent line to it at the point 2, 1. So again, we're going to use implicit differentiation, and it's a little bit less involved in this one. But again, this is a product. We're going to use the product rule here. And then we solve for y prime. And now, since we have x equals 2 and y equals 1, we can evaluate y prime, and we get 3/4. And then we can get the equation of the tangent line.